I was really looking forward to this session because next to me here is Evan Machusak from NCQA, and we're both language nerds, and both of us have been working over the past time to get our stuff, which is the .NET SDK, working together with their stuff, which is the very cool .NET CQL library. And so you already said this is going to be the culmination of the week, or also of the work that we've done in the past weeks to get this all working. So I'm really looking forward to what Evan's going to present here. So without much further ado, Evan, take it away. Woo!
Thank you guys. All right, so I'm going to be switching tasks a lot, so I hope you can settle for PowerPoint and desktop mode. So my name is Evan. I am a Director of Engineering at NCQA. And as Ewout said, we internally at NCQA have been developing some CQL technology for like 4 or 5 years now. We're a .NET shop through and through, so naturally we wanted CQL in our native stack. So we're getting to the point now where we have it in a fairly mature state, and it's time to share it with the world. So I'm very excited that we're partnering with Firely. They are the .NET SDK for HL7 everything, and so this is a perfect fit. So Ewout and I have been working together for months, along with his technical team, Reen, a couple other Firely folks. So this is the culmination of a lot of work. So the purpose of today's talk is to kind of introduce you to this SDK, how it's going to work, some of the core technologies behind it. I'll do a little bit of code showing. Unfortunately, I know everyone's going to ask, which is, how do I get my hands on this? And the answer is soon. I came here about a week early to Amsterdam to work with Ewout and his team in their offices to finish up a lot of this stuff and get ready for what you're going to see here today. But we didn't quite get 100% of it done. We need to do some legal stuff and tidy up a few things, approve some pull requests, you know. So it will be available with the 5.3 SDK. So I'll have a slide for that at the end. But as you're listening to this, and I know you'll be frothing at the mouth to get it because it'll be the coolest thing you've ever seen, and you will get it soon. So this is a bit of a preview still. So I already introduced myself, but that's a picture of me in Germany about 15 years ago. But it's the happy pretzel picture, so I thought it would be a nice smiling picture for everybody. So today we're going to talk about how to integrate CQL into .NET solutions. So as NCQA, we are a content creator. If you've seen Bryn's presentations, he shows the multiple stakeholders in the CQL ecosystem, and one of the categories he lists out is specifiers, people who write the content. We are specifiers generally. So there's a lot of folks who are doing cool stuff. I sat in a couple of presentations by Google where they're doing awesome CQL stuff at scale, and Fire streaming and all this really cool population stuff. And that's a great use case. Execution is important. But we really focus on authoring here. So the technology you're going to see was developed for that primarily. So I'm going to show you how to run digital measures that are integrated into .NET solutions, how you can run them directly from ELM files if you receive measures from other people, such as us or CMS, or anywhere you get them. And also, I'm going to show you a little bit about what we're doing with packaging. So there's some CRMI stuff that Brian Caney and Bryn are working on. And so our packages that we're creating are not 100% compliant with their IG yet, but that is the intent. So I'm going to show you how to do all that stuff. So a quick refresher on how CQL generally works. You start with CQL, which is human readable code, human writable code, although it depends on which human is writing it. And that is going to get turned into ELM, which is the actual executable measure. So if you look at the CRMI IGs surrounding what an executable library is, it has a constraint on that the ELM must be attached. So the CQL is really just a way to get into ELM, which is what all major technology, the CQF ruler, the MITRE engine, Blaze, all of these CQL technologies work off ELM ultimately. So we do not have a way currently to convert CQL directly to ELM in .NET. We are still using the Java tooling. And as I was talking to Bryn earlier just a moment ago, creating a CQL to ELM translator is not a weekend project. So We might eventually get to that point and close this loop entirely, but for the time being, ELM has to be a prerequisite. You're going to have to find a way to get your stuff into that. Fortunately, there's tooling open source and available. I will show you how that works. The Firely SDK is really primarily concerned with the second part, where we're turning Elm into C#. So we translate ELM, which is an abstract syntax tree, into C# source code. You can skip that step if you want and go straight to DLLs, but we find, at least in the authoring case, that having the C# is very important. I'm going to show you what that looks like and why we do that as part of this presentation. And then ultimately, obviously, in the last step, when you have C#, you can just use straight up MS Build, CSC compiler tools to turn it into DLLs. All right, so I'm going to show this in Visual Studio in a moment, but the basic concept is I have a Visual Studio solution which contains .NET code, and this could contain projects like ASP.NET Web applications or CLIs or any other project that integrates CQL into .NET. And this is a basic solution structure you can use to have CQL be compiled as part of your solution. So I'll show you what that looks like. And I showed this a little bit on Wednesday. So we start by creating a project, and this is actually a C# project, though I'm sure there's probably a better way to do this, but any SDK project can work here. SDK projects are projects that are considered SDK projects in the CSproj file. So what we do to enable CQL to be compiled, which we include in this input folder, we call it input because this plays nicely with the VS Code extension. So Visual Studio, unfortunately, does not have syntax highlighting. It picks up these URLs and gives them blue, but you don't get keyword highlighting in this. And this, of course, is because Visual Studio, which this is VS Community 2022, Visual Studio's extension system is much different than Visual Studio Code's. And so we do not have a language server extension that gives you syntax highlighting for VS. Visual Studio's extensions are much more complicated to build. So I thought about it, and I looked into it, and I started writing some template code for this, and I said, okay, it's been 20 years since I've done a C++ COM application, so I'm not about to do that. So we still actually use Visual Studio Code extension to actually write the CQL. We just keep it in this folder so that we can build it. So the way we do that is we import a special targets file. This is an MS Build targets project, if you've seen those before. And so we put those here. And this target is fairly straightforward. We have two steps, one of which downloads the CQL to Elm CLI. So if you don't have it, this will happen automatically. The way we accomplish that is by checking in a copy of Apache Maven. You don't have to do that in your own solutions, but we find it easy. Otherwise, we try to start up a new dev and give them their developer laptop and say, there you go, build our code, and they immediately say, oh no, I need a Maven, what does this error mean? So we just check it all in so that this is automatic. And so what this does, of course, the Maven uses this POM XML to pull in the relevant tooling that, of course, is in the CQL repository. This is the reference CQL to Elm implementation. And in the targets file, we have a simple target that is essentially finding all the CQL files in the solution, and then it is running the Java command line on this. Now, there's actually a slight problem with this. This is a choice that you can make. On one hand, you can ask it to compile all the CQL in the folder immediately every time. That has some benefits because there is a startup cost in the CLI for the Java tool. But if you do it this way, you also get incremental building. So Visual Studio will automatically understand which CQL files will change, and therefore it will only execute this command on CQL files that have been updated since the last time it built. So you can do either. In our main solution for Hedis, we actually use the other approach, and we just build everything every time. But in this demo, I showed how to do it with incremental building, and that involves doing this stuff where you define an input and an output, and this will allow Visual Studio to take advantage of that. So this project, when built, will actually, it's set up this command line to output the files into an Elm project, and specifically a JSON folder. So these are built Elm files that are also checked in. Now, in our solution for Hedis, we don't actually check these in. These are considered build folders or files. So they're get ignored in our solution. However, Again, this is a choice point. You can either check them in or not. It depends on whether you need them, whether you like to look at them and see them, and it's really use case dependent. So this will build the Elm for you. And again, we use the same basic technique in the Elm project. So to compile it, we are calling a CLI tool that is part of the SDK. It's called a packager CLI. I am, of course, directly calling the debug build of this, which is a little dicey, but that's because these are not NuGet packages yet. When we distribute this SDK throughout the industry, you guys will be receiving these things through NuGet packages, and you will not have a folder called NuGet that manually imports all the projects for the SDK inside the solution. So this will look a little different for you if you were doing this for real, and I'll have updates of these demos as part of the official release, so it'll show you how to do that with NuGet. But this is going to call this packager CLI, which does two things. The first thing, and this is based on the output parameters that you pass in. You can use a -cs parameter or a fire parameter or both, either or. So if you include the CS parameter, what it does for you is it computes the Elm into, well, compiles the Elm. Transpiles? One of those ones. It transpiles this into C# source code. And I want to keep this breakpoint because this is a demo for later. So this builds the Elm library, and I can show you what the CQL looked like so you can get some sense of what this actually looked like originally. This is a very simple measure that I made for demonstration purposes earlier today. I apologize for the lack of syntax highlighting here, but this is a very simple measure that computes your conditions in which you were identified to have been sucked into a jet engine. And then this is a definition that produces all conditions of subsequent encounters. Of course, this is with the clinician, not with the jet engine. And then the initial population is simply whether or not you've had an encounter with a jet engine, and the numerator is whether you've had a subsequent encounter. This is a very simple analogy of a standard follow-up measure that you might have, where you have a condition like depression screening is a good example. This is modeled somewhat after that. So we start with a couple of defines, and in the C# that we generate, we'll have things like the jet engine conditions, which is this stuff here. Now, of course, the reason it looks kind of dicey, right? This looks like very much generated code because it is. I am turning what is ultimately a functional expression, a single return value, into a function that has intermediate steps and local variables. And why we do this because, as you can see, I have a breakpoint set down here. When we try to debug this, when we first translated CQL into C#, we made it look much like the CQL, where it's a single statement. And we found that from a debugging perspective, that really wasn't much of an improvement, actually. So we spent some time trying to pick apart the individual expressions and declaring them as local variables here. And so we, of course, have a very rudimentary way in which we pick variable names. So you'll see A, B, C, D, and E. And the code is kind of gnarly, but it's not really meant to be looked at as much as it is compiled. It's only really looked at if you are in the process of authoring the measure, such as we do on a daily basis. So for us, this is really important because we test our content before we deliver it. And this type of breakpoint setting we find really useful. I'll show you a little demo of that at the end. So at a glance, this contains all the code that was generated. We have some levels of caching, which is why you see this patient and then a patient value. For our C# programmers in the audience, we are using lazies here so that we cache the value. This is important when you have defines that reference each other. You only want to compute the initial population once. You don't need to compute it over and over again. So there's some efficiency baked into this, but it still has some room for improvement. So, so once you have this project, there's a lot you can do with it. So you can simply compile this, and it will create a DLL for you. Once you have a DLL, you can do virtually anything you want with it. So in this simple demo, I have created a unit test project. So I have simply added this as a project reference. And this allows me to go to our first demo here, where I can show you how to execute a library using this SDK. So I've created a little helper here to create me a measurement period parameter because my measures use this. This is kind of ugly code, so I create a helper for this. So if we want to compute the numerator, and I'm not using the DevDays measure for this, but rather I am using a measure that is close to my own heart because this is a HEDIS measure from days of gone by. This is the 2022 version, and this is a measure that we donate to the community as a sample. This whole project here, all these CQL files, they may look familiar to you if you come to the Connectathons, because this is essentially the track files that we use for Connectathon testing. So this is the version that's included in there. So I picked this one because it's a little bit more complicated and it looks like more like a real measure. So this has a numerator in it, and if I want to compute the numerator for this particular patient, I can do it in a couple of lines of code. So I'm creating a bundle. This is a Firely SDK bundle. Historically, the way CQL is executed is with patient everything bundles. So typically that is how we run and test, although this SDK allows you to change that. You can have it load data from anywhere, really. You just have to implement an interface. So the only interface we've implemented right now for the demo in the SDK is just a sample bundle retriever, so that it works similarly to how the VS Code extension would work, so you can test that way as well. You need value sets generally for these measures. If you look at the BCS measure, it has many value sets declared. For the purposes of this demo, I didn't feel the need to load a bunch of them and all that, but essentially this usage shows you that if you have a set of value sets that you've deserialized from, for example, a set of file resources you may have on disk, all you need to do is have them in a list, and you can call this method called toValueSetDictionary. What this is doing for you is it's hashing the codes in the systems and creating a highly optimized way of quickly looking up codes and value sets. Measurement is essentially two things. It is, do you have the right code on this resource, and is the resource in the right time frame? That's probably 95% of all quality measurement. And then the other 5% is where it gets hard. So having a highly optimized data structure that will quickly tell you whether your codes are in your value sets or not is critical to performance. So we have a object that we call a context. It's a CQL context. This is the object that contains all of the information you need to pass in to the runtime to be able to execute a measure that you've created this way. So there's a helper factory function in the Firely SDK. This naming is subject to change. We might just drop the Firely part and just call it CQL context, but this is one of these situations where it's in preview. So you can pass in a patient everything bundle, and you can pass in the parameters, which is the measurement period. So this is how you would pass in data such as this. At the beginning of the file, you need to pass in the measurement period. That is a parameter to this context. It's a simple dictionary. And then you pass in the value sets. These are all optional, so theoretically you can create a context that has nothing in it, no definitions, or no data, no bundle, no parameters, no value sets, and it will still execute. You just won't get any results generally. And all you need to do at that point is since you have a project reference to this, you have access to these classes that we generated, and you can instantiate them like any other class. You can pass in the context, and then you can call these methods. So this will create the numerator and or evaluate the numerator, and obviously since I'm not passing in any value sets or any patient data, I can assert with confidence that the numerator will be false for this particular demo. So that's one usage that we have that you can use this SDK with. Another one is a little bit more interesting, and this is based on this parameter that I showed you a second ago, where you can actually ask the packager to package you file resources. So what this does, I have this being set to send it straight to my test project. And so these are here in this folder. And I have what looks to be approximately CRMI packages. They're not quite, so no nitpicking, Brian. These will contain all of the related artifacts. These are all the dependencies that this particular library has. This is just the first level, so this is all the includes in the file. We have the parameters, which are both in and out parameters. So this file resource will indicate what the outputs of the CQL library would be. So this includes things like we compute the October 1, 2 years prior to the measurement period. That's a fact of BCS that's important. It's defined as an out parameter, and we'll tell you it's a date time. And we have all this stuff. The other thing that we do that's a little bit different than the standard CRMI stuff is we have attachments as the content, which is how you do it. In addition to the Elm and the CQL file, we also include two other items when you package with the CLI. You get the C#, so this is the text of the C# class that we generated. And additionally, this octet stream, that's the MIME type for a DLL. So when you package with into file resources, what we end up actually doing is we take every library you have and we create a single DLL with a single class in it. And this allows you to distribute them and pull them into projects. And as long as the project has, to be more specific, as long as the app domain that you're currently executing in has all of the references loaded, so it has the CQL SDK loaded into it, you can load these DLLs dynamically from content. And this allows you to essentially run these libraries with no additional tooling. So, other than just the SDK, of course. So this demonstration, this code shows you how to create what's called an assembly load context. This is a .NET Core, I think, or now it's .NET 5 and 6. It's the new method that is similar to app domain that used to exist back in the .NET framework. So it creates this assembly load context, and I could show you the source code for this, but it's in the SDK if you want to see it. It's just deserializing all the fire, base 64 decoding those assembly byte arrays and loading them as assemblies. And I'm doing the same thing here. I'm creating an empty bundle, and I'm creating empty value sets. And I'm creating a context here, and I have a helper method. This is an extension method on the assembly load context class called run. Lib and version are the actual libraries I want to run. So in this case, I want BCS. And I'm not able to call numerator directly in this situation because these DLLs were dynamically loaded. So that means I can't easily instantiate a BCS instance. Instead, what I have to do is compute the results, and this result is a dictionary. This has all of the outputs by name. So when I run this library with this input, I will get a dictionary containing numerator and all the other outputs. And I'm asserting that this numerator will be a Boolean. I have to know that somewhat ahead of time if you run in this context. I'm asserting that it's a nullable Boolean, and I'm going to assert that it's going to be false. And the last usage, which is very common, this is how most of the other engines currently work, is you can run Elm directly. So rather than have to go through the effort of running the package or CLI or doing any of that, if you simply have Elm files handy in a directory, or you've extracted them from the packages to somewhere on disk, you can run those directly as well. So here I'm creating a relative path. These dots are a relative path from the binary directory of this test project all the way back up to here, this Elm JSON folder. So I'm essentially pulling this folder in. And again, I can load resources. I can load Elm from this directory. In this unit test, I have a couple of stopwatches here. The demonstration that I can show you in a minute here when I run this will show you that the first initial load of the Elm is a little slow. It takes about 10 seconds because what it's doing is it's converting it all to C# and then compiling it as well. So it's invoking all the Roslyn tooling to do all of that for you in memory. So the reason that this usage is the way it is that you want to keep this assembly load context. Once you have it, then you can call run multiple times and it's pretty quick. But when you load it initially, it takes a while. So you want to essentially load it all into memory, into this assembly load context, and then you can run as many of these libraries as you like. And again, it has the same dynamic usage that the loading from resource does, because you don't necessarily know for certain at this level whether you have a numerator in the output. You just have to know that because you know what you're running. Or you don't care because you're not making assertions and you just want the output. So if you were going to stick this into something like a CI/CD chain, you don't necessarily care what the values are, what their names are. You just want to take those results and put them somewhere, like into an analytics store or something like that. And then I have finally just another test that's using our actual DevDays demo CQL file that I showed you about being sucked into a jet engine. And you can see, maybe you can see, let's show you, this is failing currently. and I'm going to show you how we debug this in real life. So let me make sure I have my breakpoints set, which I should. So I'm going to open my DevDays CS file, and I have a breakpoint here, which is in the jet engine conditions. So this is the where clause, essentially, of the jet engine condition. So if I debug this, fingers crossed, cursive demos, let's see if this works. I should hit this breakpoint, I hope. Okay. So now I'm essentially debugging CQL, which is pretty cool. So if I look at my locals, I can see the values of all these incredibly well-named variables, such as A and C and B and all that. So I can see when I'm looking at what I'm really looking for here, and I'll show you how the thought process works. It's hard to tell just by variable names, so you kind of have to take a look at the code and understand, okay, what is it actually doing? So before I even look at this, the way I would debug this is I would look at the CQL file. And I know enough about CQL, and I know enough about how I translate it to have some semblance of understanding of what it's going to look like in C#. But when I look at jet engine conditions, I can see that this is a simple query. I'm starting with a condition retrieve, which is going to give me all the conditions in the bundle. And this is why we use patient everything bundles, because it makes this very simple. I don't have to worry about getting these conditions only for this one patient. By declaring that this library is a context patient library, it is implying that there is one patient in context. So that means that the conditions that I retrieve are only for that patient and only. So this is the responsibility of our data retriever. So if we're using patient everything bundles, you have one patient and a bunch of conditions. If you were doing something more sophisticated, like using a Firely client to go to a server and pull data back, you would need to know what patient you're pulling it for, and then you'd have to do a condition with a subject search, for example. So this where statement is pretty simple. What I'm doing is I am checking that the code for this condition is equivalent to being sucked into a jet engine. The reason I'm doing it this way, as opposed to a syntax you may see more often in demos where you say something like jet engine incidents, this would be a value set. For the purposes of this demo, I did not feel the need to make a value set here, but that's normally what you do. But since I'm declaring codes explicitly, it's a little easier and clearer to do it this way. And then I am checking to see that the onset of this condition is within the measurement period. I'm not interested in all of the times you were sucked into a jet engine prior to this measurement period. I only want to know the ones that happened this year. So when I look back at the C# here, that I'm looking at here, I can kind of get a sense of what's going on. I'm calling a method called retrieve by value set. I'm passing in null because there was no value set filter specified. So I'm getting conditions. So my A variable is going to be my conditions. And this big hairy function, when I look at how it's actually used, you can see there's a where statement being used in conjunction with this function, which is the predicate. So, and when I look at the body of this, you can get a sense that this is the where statement. So the first thing I'm doing here is checking codings to see if you have a coding match. And I'm checking to see if there exists such a thing, and this correlates to this statement here, if that exists. So I'm checking that, and I am checking to see what the onset is. I'm casting it as a fire date time right here on this line, which is exactly the same as what I'm doing here. I'm asserting essentially that the condition onset is going to be a date time. Normally, onset can be anything. It can be a period, an age, a range. There's a whole category of things it can be. But I'm saying for this case, it's going to be a date time. And I'm checking that it's in the measurement period. And so I am computing the measurement period here. So now I have a sense that, okay, I is going to be the date that I computed, that I pulled out of the condition. And measurement period is going to be the thing I'm checking it at, and I'm calling element in interval. Element in interval is a CQL operator that's defined in the spec. It's just called in the spec, but this is checking that a specific thing is within an interval. And you can see that the parameters I'm passing in here, I'm passing in I and I'm passing in J. I is 2022, J is 2023. This is the bug I've discovered. This is clearly going to return false. So therefore, and I can test that actually if I like, where I can take this into the intermediate window. So if I pop this in here, let's see if it accepts this space. It does. So it's telling me that it is not, in fact, in the interval. And I can see what G is. I can see what K is, theoretically, if I'm typing these incorrectly. This is actually the and, I'm sorry. I want to check this guy. This is what I want to look at. See if it accepts this. Right. So in this case, I want to look at what I is. I want to look at what J is. And I can quickly confirm that these are definitely not going to match. So this is how we debug CQL when we have issues like this. And of course, this test is fairly contrived because we are explicitly creating dates here, and it should be fairly obvious what this bug is just by statically analyzing the code. But in the real world, what we actually do is we take thousands and thousands of patients in our NCQA test decks, if you're familiar with those. I can actually show you one if we have some time, but we test these measures against tens of thousands, hundreds of thousands of patients in some cases. So the breast cancer decks that we use are about 30,000 patients. So you'll get these patients that have failures in random places that you don't understand why, but I can put breakpoints in code when I have a theory on what's going on, and this makes things real simple. So I can tell right away, I can just stop this debugging. I think I see my error, and I can fix these to be proper dates that are in 2023. Of course, in the real world, you can't just change your source data, so you have to come up with more clever solutions here. But if I run this now, it should pass. I hope. We shall see. So there we have it, we pass. So we use this technique, and I'll show you now a little bit about what we do internally. Again, this you might see for the blink of an eye some intellectual property here, so no stealing it. But this is actually our work in progress HEDIS solution. So we have quite a few files here. This is how we structure our HEDIS measures. We have resource libraries. We have topical libraries that focus on clinical areas that touch many of our measures. We have some general libraries like fire helpers. We have a fire common that relates only to fire concepts. And then we have measures. We organize them this way because it's convenient. And so in order to support this foldering, by the way, we had to fork the CQL to Elm compiler, actually. So it was pretty easy to do, I will say, but we did fork it. So we used some slightly custom tooling for this, but the only thing it really does functionally is give us folders, which we really wanted. So we have tests that we wrote for each of these big concepts. We have quite a big set of unit tests, and let's see, I don't know how many we have. We have 2,096 unit tests covering all kinds of various things. So we have an abatement date range concept that we have in a library, and so we have some test data like this. This gives us high degrees of confidence that our code is correct. So when we write a new measure and we need to come up with an abatement date range or something like that, we want to use a range in an abatement. We know this is going to work because we've unit tested it to death. And so we've integrated this into a Visual Studio pipeline. So this could be done in Git, of course, as well, but Visual Studio code is, Visual Studio integrates nicely with NCQA's Microsoft's proprietary tooling, Azure DevOps, that we've been using for many, many years. So this is a pipeline. You can see during the pipeline we run all of those tests. But we also do something a little bit more interesting, which is because this is all in C#, it makes it really easy for us to create pretty sophisticated build pipelines. So we have tasks in this build pipeline that test and build our measures, and they run them against our test decks. When they run them against their test decks and they pass, then we use the packager to package them into Fire resources, and we put them downstream into a place where our software can pick them up and use them. So it's pretty neat. And you can see the times that some of these take. What's interesting about this is that there's some inflation because this involves pulling large files from Git and unzipping them and deserializing them. There's a lot of overhead here. But the typical decks, they vary quite a bit. So AIS only takes a minute, but then something like EED takes 11 minutes. So there's quite a bit of variability in the way the measure performs based on how the CQL is written, how big the deck is, and so on. So it's pretty neat. Let me make sure I'm not missing anything that I want to talk about since we're almost at time. I talked about that. Right. So other ideas. These are some things we've done internally with this technology. The first is that we package and distribute our compiled measures into NuGet. As part of this build pipeline, we publish a NuGet package into our private artifact store. So that means every application at NCQA at any time can pull in HEDIS measures. We actually use this for a second project that Anne's team actually works on, which is a special set of DRP measures that we created for NCQA's recognition programs. Using this technology, we were able to compile CQL into a NuGet package, which we then imported into a web application and then made available in a user interface in an ASP.NET web application, which is pretty cool. So we do that already. I currently have someone prototyping deployment of measures into an Azure function as part of an Azure Data Factory so that you can stream Fire out of a Fire server through an Azure Data Factory, run HEDIS on it by calling an Azure function. And of course, you can do more generically. You can put these into ETL pipelines of any kind, Spark, Kafka, all sorts of cool stuff. So basically anything you can do with .NET, you can do with CQL using a couple of simple MS Build scripts and the Firely SDK. So I hope you got a sense of how you can use this SDK to integrate CQL into Visual Studio and how you can now integrate CQL measures directly into .NET stacks. And I should say any stack that integrates with .NET can also leverage this. So if you have any interoperability with, let's say, Python running .NET, pulling in the CLR, for example, you could do this in Python as well. So again, how do I get this? Currently, you cannot as of today. We have to add license agreements to all the C# header files and a couple other things. So Firely is publishing a 5.3 version of their overall SDK, and that will be the first version that we ship the CQL SDK preview, which will probably have a separate version. It won't be 5.3, it'll be 0.5, something like that, to indicate that it's preview. We are still evolving the public surface of this API, so some of the demo I showed you today, that may not stick exactly the way it is currently, but it'll be something similarly simple. So we're putting in preview because we don't want people to start writing production code on this quite yet. So we have a soft target here of getting the full version 1.0 release that you can confidently build production on by September, the working group meeting in Phoenix. That is the goal. If not, if we don't quite get over the finish line, we should absolutely have this done by no later than January. So by the end of the year for sure. And that's it. Questions? Thank you. Oh no, not this guy.
I'll start with the hardest.
Can you show me the ATAN function? Just kidding.
Yes, well you asked.
No. I'm just totally. I'm curious about, like, I love the use case of developing CQL, but I'm wondering, I think you mentioned it, the generated .NET C# code doesn't resemble the CQL at all. So there's like, you're going through this mental map of interrogating the CQL and then trying to figure out why did you not decide to make the generated C# code look more like the CQL code so it would be easier to debug?
So good question. So as I mentioned, we did originally, and in fact it's an option. So I can probably dig it up. If you're interested in that being a first-class option, we can make this optional. But there is, during our C# generation, we start with expressions that look very much like the original CQL. They're entirely just Lambda functions, Lambda calculus, of course. I studied it. So we actually start with those, and we use a series of expression visitors. These are standard .NET classes that are available in the system.link.expressions namespace. And so the one that is doing the conversion into the sequence of local variables is this one. And we could just simply not do it. And if we didn't, then it would look very much like the CQL, almost exactly like the CQL as a matter of fact. And we found through trial and error, there were two things that were true. The first is it was less performant. The reason for that is because during this we also memoize expressions. So if the same expression is used twice within a function, we have a local variable now, so we deduplicate it. But secondly, it was not any easier to debug, really, because you could not set breakpoints very easily. It's hard to work with a set of complicated expressions, and consider that in CQL it says if this, then that. Well, in C#, that turns into a conditional, question mark, colon. Not easy to debug, even a little. So we found, trying that it just didn't work. So this block transformer is actually a lot of ugly code that was hard to write, and I would have preferred not to need it, but we found it necessary. So that said, you don't have to use the C# at all. You can just take it straight to a DLL, or we can enable you to turn this off and see what it looks like. I suspect you will decide to always keep it on. A good question. Thank you.
Right. I have another question in the room. By the way, for those online, I have seen your questions, so I will get to them as well.
Yeah, thank you. So with this engine, I was wondering if you can evaluate a measure on multiple patients simultaneously. Is that possible?
On multiple patients simultaneously? Yes, theoretically. So that's kind of a deep question.
Yeah, so the reason I'm asking it because I was involved in a project where we used cohort definitions in
Right.
CQL, and then one of the use cases was that we wanted to know for an entire set of patients.
Right. So there's no reason that you have to write a library that's context patient. You could very easily not. And then, for example, you could do something like patients, and you can then retrieve patient. Right. So if you were trying to load multiple patients at a time, you could do this in a variety of ways. For example, you could just use the bundle data retriever and take tons of bundles or tons of patients, putting them into one bundle. Like, for example, I'm not enough of a Fire server guy to know that if you pull a group down from a Fire server RESTfully, do you get a list? Do you get a bundle? Right. So suppose you downloaded that. Well, you can do that, but then you are taking in the responsibility of saying something like, correlating these conditions to the patients involved. So you'd have to create relationship queries that would do that for you. So you can. And there is another option. This is it's an extensibility point, which I don't have in this particular solution. But there's a simple interface that you can implement called iDataRetriever. And what it does is it simply asks you to return the conditions. So when these types of statements are hit, you are responsible for then returning those. So if you wanted to create an iDataRetriever that was sophisticated, that allowed multiple patients and would pull the correct conditions based on a key, you could find a way to do that. If you're interested in that, I would be happy to talk it through with you and possibly just create a demo example of how to do that. We can include that in a demo repository about. Yeah, good question.
All right. I'll pick an online question now. I'm unclear where the CQL is getting executed. Is that in the Fire server or on your machine? The question I'm asking is, could you send the C# version, could you send this code to any Fire server and execute the C# version of the CQL?
So this is really more of a question for Rich and the Firely server guys to answer of how they're going to do that. All CQL engines that I'm aware of currently, except for Blaze, which is the closure project that Alex is working on, generally speaking, you have to bring the data down to the execution. So this is all running on my machine. If you had a server that was capable of running C#, I did actually have a demo that I started, but I didn't think it was good enough to show. But I created a very simple Fire API web application that tries to implement evaluate library using this stuff. So theoretically, this would run on a server if I published this, right? But ultimately, this isn't something like SQL where it can miraculously run on SQL Server or something like that. It still requires a C# execution environment to run this. How you turn that into a server product is, well, you can, right? So I created a very, very, very simple thing that just creates a library evaluate that's going to run all patients, and I have these little handlers that will evaluate this. It's half-baked, so I didn't show it, but yeah. I hope that answers that question.
Yep. After the execution of the CQL, how do you know which patients fall under numerator and denominator? Does it return patient IDs?
So again, this is kind of the am I running multiple patients at a time question. So I could show you how we do things. Let me see if I have something that makes sense. So we have some deck tests. So if I categorize these by project, see. So we have tests, and all right, so these tests that are like A, B, 13, 16s, these run entire decks, and the way they work is by pulling a zip file. I don't have these downloaded to my local machine because they're huge, but what we do is we open up zip files containing patient everything bundles, which are converted from our certification decks. And so we set up all the parameters which we want to be for the run, and we do a parallel for each, where each zip entry is a JSON serialized bundle. We unzip it, we create the context, and then we are now running these definitions for each bundle that we're using, and we are checking these against a score key. So that is what this code down here is doing, is executing. It's checking a score key file, which we have, that tells you whether you're in the numerator or not, and we make sure that our CQL agrees and produces the correct value. So we do it with a simple parallel for each loop. But you could do something more sophisticated where you created a server product that was able to evaluate an entire group, and you could produce for example, a bundle full of measure report resources that are subject level. You can do that too. But typically this execution is one at a time, but it depends on how you write the CQL. So you can write CQL that works on populations. It's just, we don't do that very often in the industry because it makes the CQL harder to write, because now you're taking on all the responsibility of doing all of the joining. So conditions with subjects, and you end up with CQL that looks really tricky because you have nested queries, and it's harder to write. So we typically do this one at a time.
I guess my question is around management, deployment, and security. Obviously, if you're going to be putting DLLs or assemblies in there, you've got a massive security hole. Is there a capacity for running, I saw you had the expressions, can you actually do it at that layer, so you're actually running the expression?
Yes. I didn't show it because it's a little gnarly, and I didn't want to go deep into where you're going, which is, can you just take these expressions, turn them into delegates, and run them all in memory? The answer is yes.
Yeah.
Because
that then ducks the issues of someone's shoved some random malware.
Yes, exactly. So theoretically, yeah, if you wanted to accept these types of bundles, you better trust the source. Right?
Yeah.
So certainly, we were actually just talking earlier today about figuring out a way to digitally sign these in such a way that you could trust me. You have my key, you know these came from me, you know I'm not going to hack you. But in the CQL context class, let me see if I can grab it real quick.
Thank you.
Sure. Where's my context? Firely context create, just F12 this, and the CQL context. So one of the options that you can pass in is delegates. You don't have to compile this to C#. You can run it intermediarily. It's not a demo I showed, but it is possible. And that was the first use case we did, actually. But it's not fun to debug because if you run it as a delegate and it throws an exception somewhere, you don't have a stack trace. So it's very annoying.
We have time for one more question, I think. Can you show what is the output of the execution? Will it be saved as a measure report file resource?
It's up to you. So we have tooling that we wrote based on top of this that can produce measure reports. It can also produce parameters resources. I think that's the CRMI way, but frankly, we were doing that prior to even hearing about it because it makes sense, right? It's the thing to do. So there is code. I do have code that does it. In this demo, the default way in which we output things, it's the absolute simplest thing, is that these results, when you run them this way, these are dictionaries. You can fairly trivially transform those into the file resources you want, especially if you know this is a measure. That is actually one of the harder parts of this ecosystem, is how do you know it's a measure. So internally what we do, I can show you this just real quick. We have a way of identifying our measures as different than libraries in our HEDIS stuff because we tag. I'll show you what we do. We put groups and population tags on things, and these correlate directly to values on measure reports, and then we have tooling that understands these tags. You do get access to the tags in this, this framework, which you end up getting. I'll show you the other class real quick. I'll just show you what it would look like. In the C# source code, if you had those annotations on there, you would get this. You'd get a CQL tag, and it would say something like group. If I can type here, it would say group 1, something like that. And then you can use tag tooling to identify that this function should be, the result of this should equate to a measure report group 1 initial population. So that's how we do it. I didn't put that in the SDK, but I can potentially. It's just a matter of, do we want to standardize what I just showed you with these tags? This is not a standard. This is something we invented. So I'm trying to be standards compliant here in the SDK level. So it just produces dictionaries at the moment.
All right, thanks. Thanks a lot. We're at time.
Great.
Thanks for the presentation. And
thank you guys. I appreciate it.